looking at similar triangles. The triangle similarity theorem says that if two triangles are similar, then their sides are proportional. What that means is, do those look, no, those don't look very similar. Sorry, similar triangles, remember, have the same shape, but different sizes. So in similar triangles, all of the angles are congruent. So let's say my first triangle is ABC, and let's say DEF is actually similar to ABC. What proportional means is that you can set up a ratio of sides, and the ratios are the same, equal. So the ratio of AB to DE would be the same as the ratio of BC to EF, which would be the same as the ratio of AC to DF. So we're going to use that theorem to solve for missing sides in similar triangles. So our first example is we're given the triangles, find the missing sides. So my first goal is to find the two corresponding sides that I know so that I have a ratio without a variable. So I'm looking at AB to DE. So I'm going to set up my first ratio as 3/2. And then pick a variable to solve for. I'll solve for x first. So because I started with triangle ABC, that was the top number in my ratio, I have to start with x as the top number in my second ratio. And CB corresponds to FE, so 3/2 equals x over 3. Remember, to solve a proportion, we cross multiply, so 3 times 3 gives me 9. 9 equals 2 times x. So dividing both sides by 2, I get 4.5. To solve for y, I'm going to start with that same ratio. And again, I can't start with y. I have to start with the side from triangle ABC. So equals 4 over y. Cross multiplying, 3y equals 8. Dividing by 3, I get 8/3 or 2 2/3. Last example, let's take a look at a word problem. So Jason was standing 3 feet from a mirror and saw the top of the head of his partner in the reflection, who was 3.5 feet from the mirror. I like visuals. By the way, I just realized, so I wrote this example. I did this example with my Algebra 1 class when we did ratios and proportions. The mirror was on the floor. Normally when you think mirror, you're thinking standing in front of it. But in this case, we had a little mirror that was on the floor. Jason was 3 feet away from the mirror. And his partner was 3.5 feet away from the mirror. Obviously, people stand perpendicular to the ground. And so what he did was he was looking down at the mirror and saw the reflection of his partner. Call it P. So there's Jason's partner. Jason is 5.5 feet tall, and we're wondering how tall is his partner. So here's our visual aid to help us set up our proportion. So we're going to start with 5.5 over x equals 3 over 3.5. So if you're looking at this, there's about, 6 or 8 different ways that you could set up this proportion and still get it solved correctly. You don't have to do side from the first triangle over side from the second triangle. You could do Jason's height over his distance from the mirror equals his partner's height over his partner's distance from the mirror. If you take a look, your cross products, 5.5 times 3.5 equals 3x. So as long as those cross products are the same, then you and your partner could set up the problem differently, but still get the same answer. 5.5 times 3.5 gives us 19 1/4. So dividing both sides by 3, I got 6.417 feet, but we never say someone's 6.4 feet tall. So I converted that to inches. So I took the 0.417 and I multiplied by 12 because there's 12 inches per foot, and I got his partner was 6 feet 5 inches tall.